Everyone. So everyone can hear me clearly.
Yes.
Okay. So uh, for this one to work smoothly, you should have your Fiji ImageJ running on your desktop or the computer, getting, and have the material I send during the weekend open. So goes through those goes through those samples. Okay, I will start it. So my name is Naiding. I work as the senior scientist for the Brigham Women Hospital, the neurotechnology studio. This is the first part of our series, the ImageJ for the beginners. So today we're actually talking about the really basic stuff on the ImageJ, how to open image, save image, and simple simple measurement and selected the region of the interest. Okay? So I'm going to share my screen. Then we'll go through the examples on the I it's among the materials I send you during the weekend. After each section, I will stop and check on the chat, and then we can discuss in the specific questions you have regarding to that section. Okay? So I'm going to go to my share the screen. So this is the material I sent through the weekend. You should have your Fiji Imaging J open. And in that, we have the Imaging J for the beginner one. There's a PDF file. It's basically the PowerPoint that we're going to use for today. You can open that as a reference. The Imaging J, as you can see, once you open it, it only has those small windows, unlike other commercial software, which people they tend to have a big window occupy your whole screen. It tends to have a very small window, but doesn't mean it's a very simple software. And if you go through all the manual trees, you will see there are actually quite some functions to find it. And you need to get experience, practice more to know where those functions are. So to make this process simple, in this seminar series, whenever in the handout you see the red text, that means where you can find the specific functions in the manual tree. Like if you want to have a stack image, you want to reverse that stack, you can go through, we'll show you as the image stack to reverse. So the first one is always the root manual. So you have a stack, you want to reverse the stack. What you can do is you go through this, that will be image, stacks, tools, and reverse. So all the functions we're going to use through the seminar series, all the red text is show you where you can find these functions. So first thing, if you want to, you have the ImageJ open. I want you to test on this one. You follow this red text, edit options, then you go to the memory and the threads. Okay? So this is on my computer. I will edit option. This is the memory and do not change any of these settings, at least for now. So basically what you're looking at is that when you install the ImageJ will try to assess how many RAMs the program can use. The default setting is 75% of your computer RAM. So in this case, you can see on my computer, I have about 8 gigabyte RAM. So it will set the maximum memory about 6 GB. And this is, do not change it to be higher. Getting on this maximum the memory one. In this one, when I do the screenshots, that's on my laptop. I have a 32 GB RAM, so they will suggest that like 24. Okay? So the basic point is do not set the maximum memory over 70%, 75% of your RAM. Normally, you can just go with the default one. They just allow the ImageJ to use the maximum available RAM that it can to go through your imaging processing. So this is first one we can check. And then we'll say the next, you will check this is edit options, color, and also process binary options. I want you to set it as exactly the same as what I'm showing up here. Getting the colors. I will explain this one later. Getting. So if you go this together, so first is you go to edit options, color, this part. So make sure the foreground color set as white, background as black, selection as yellow. Then click OK. The second one is the process binary options. Process binary option. Just make sure this black background one is checked. Okay. And to set this is not a requirement, but normally what we tell the system is that when I'm working on the image, I consider the high intensity pixel, which is more like a white pixels, are the pixels I'm interested, are the signals I'm interested, not the black one. Because I normally work with confocal, the fluorescence images. It's always the background is black. Your signal is at a higher intensity. So I set this up. If you're looking at, if you're working most on the gel images, like the Western blot scan, and mostly the background is white, your gel band is black. So in that case, when you work on that, you may want to uncheck this. So in your case, the white is the background. But throughout the whole series, the seminar series, we were assuming, in our case, when the intensity level is low, it belongs to the background. When the intensity level is high, it belongs to our signal. Just make sure the ImageJ consider this. So when you begin to analyze your image, it analyzes the white object, not the background. So once we set up this two, okay, we're going to go through in the folders. We'll go to the open image file format folder. It goes into. So one of the, I think the greatest advantage for the ImageJ is it can almost open every single scientific equipment image format. It's compared to other commercial software like the MATLAB or the Imaris, the Velocity. Getting it's almost certain once you have an image from a scientific equipment, it has certain plugin already installed in ImageJ that can open it. So here I just show you some examples. Like for, if you go to the bottom one, that's the size, LSM. If you're doing the confocal using the size, the system, it will say the, about a few years ago, the size, the confocal format is .lsm. To open the image, you just directly drag it into the ImageJ main menu. It will open it, okay, as you can see here. And you can use this one, the magnifier. If you're in the Windows, the left click will magnify it, the right click will zoom out. In the Mac, I'm not sure, you can check, I'm not really a Mac person. You can see this is a 3-channel image. green, red, blue, getting? And once you have this image, you can go through multiple the functions. You can work on the image. You can go through the image color. You can split the channels. So currently, there's 3 channels combined together. I'll say I want to go through this one, split the channels. So now they give you the individual channel. This is channel 1, which is green. Channel 2 is the red color. Channel 2. And then if you want to say, I want to combine these 3 together so I can choose 3 colors at the same time in the image, you can go back here for the image color. We first choose the 3 channel. Now I'm going to merge the channels. So now it will ask you to which channel you want to show it as red. So I know that here the C2 is the red channel. So I will choose this. Red should be C2. The green should be the C1. And the blue is the C3. And then we merge as RGB image. And once you have it, you can say, I want to save it. You can use the file, save as. It gives you a lot of selections, the image format to say. But we will strongly suggest you only save as TIFF. I will explain later in the next section. Okay? Always save it as TIFF. Almost always. Okay? That's just just to be safe. Okay? So as you can see in other image one, you can just drag this in. This it won't start automatically, but it will start as something called bioformat import option. The bioformat is a plugin that's developed and maintained by a group at the University of Wisconsin, okay? Part of what we call the NoSci project. Oh, so this is a plugin which guarantee almost the ImageJ can open every single scientific image format. So when you open the image, if you show up this bioformat import the options, I normally will say I uncheck everything. I want to open it as raw as possible. Later on, you can try to check on those 3 settings to see what the result is. Just to make sure this will stack as the hyperstack. That is the most common used the options. So I use the hyperstack. I uncheck everything. I open it. So now it opens as an image. You will see now you look at it, it's kind of black. Getting? This doesn't mean there's no signal in it. So once you move your mouse in, if you begin to check this part in the main menu, just below all those 3 buttons, you begin to see this shows you now your X and Y location, and also the intensity value for that pixel. If I move around, as you can see, actually we have quite some intensity around. Okay? It doesn't show up. It's because this is actually a 16-bit image. Compared to the maximum intensity, is kind of very low. So when it show up, it's more like black. You just need to do a simple brightness and the contrast adjustment. So in the ImageJ, you will do is image, adjust brightness and contrast. So you may wonder like, how do I know all those 3 functions are? Unfortunately, there's not a simple way to know this. You just need to practice more. In the folder, I have a file called the simple functions, which I list about 30, I think the most commonly used functions in the ImageJ. You can use that reference. But later on, once you practice on the software more, you will know where to find those 3 functions. So here is we just adjust the brightness and contrast of the image. I click on this one. It gives me this. And you can just click the auto. It adjusts the brightness and contrast. So this is actually a bright field image of a wound, the assay. That's people do a scratch and then there's no cell here, you can see all the cells. So basically, you can try on the different the file set. You just drag it into this. Like for this one, .fits, I actually never know what that file format is. I only know that's people using in the astronomic, the field, get it? You can just drag it in. You can see the difference. I can check the brightness, the contrast. Let's give me. Or I can also try this one. This called the .dcm. That's some like a medical image about, I think about the retina scanner. So I drag it into this. Now it show me a kind of the error. It said some the Java IO exceptions. So if you cannot directly open the image by drag it to the ImageJ main window, what you can do is we will go that into a hardware. I will go to the plugin, find the bioformat plugin. If you install the Fiji ImageJ, this plugin should already in it. If you just install the ImageJ from the NIH website, that you may have to install it by yourself. So that's a bioformat. I will use a bioformat importer, and I will choose this one. I found it, where to open it. To open again, this bioformat option, I choose the hyperstack, everything. I believe this is the retina scanner. Ready? And then after that, you can save it as a TIFF image. Okay? Once you save as TIFF, you can open it in any other imaging software, so that will make your file be universal accessible. Okay? So mostly you just drag this file into the ImageJ window. It will open it. Or you can also check on, if you cannot open, you can also try the plugin bioformat importer. Okay? If they still cannot do it, that I would say you're working on a very kind of a rare or strange image format. You can actually directly check with the people in the NOSI program. If you check on the bioformat, it's a group in the University of Wisconsin. You can actually send them your file format, one file. They may work on it. I used to do it quite some time, several years ago. I sent him a file format, and a few days later, they said you can just upgrade to the ImageJ again, just update it, and then it can open that format. So this is to open the image. That's actually a very big advantage for the ImageJ. It basically can open every single image format you have. But when you save the image, we will strongly suggest you save as a TIFF format. Especially do not save as a JPEG format. Ready? It's because when you save as a JPEG format, it will change your pixel intensity. So it basically change your data. And you cannot blame the ImageJ to do that because you ask it to save as JPEG. And when you say save as JPEG, you automatically agree to say it's okay to change the pixel intensity. Okay? Once you change the pixel intensity, we can't really do any kind of a measurements on it. It's not reliable because not the same as a raw image. And to show you this, we will go to an example. If it goes to the save image folder, I will have, this is called the macro file, getting? It's a kind of a coding, the program coding for the ImageJ. The same as all other image, the files, to open this one, you just drag it into the ImageJ. So what this does, this creates an image about 15 pixel in X, 15 pixel in Y. Everything is black. All pixel is black. All pixel intensity is 0, but only about 4 pixels. I assign them to a specific intensity. So if I run this one, it will gives me an image. As we move around, you can check on the XY coordinate and the intensity here at this bar. All the pixels intensity is 0. Only 4 of them with the intensity 50, 100, 150, 200. So here we create an image. We know exactly what pixel intensity are. Then I will save this image as TIFF and as JPEG. Then we'll say if actually we keep the pixel intensity after we save it. So I create this image. I will first save it as TIFF. I will use the file, save as. I will save as TIFF. I will go to the save image. I will actually save this one as TIFF. I will overwrite this. I will say this is the name is TIFF. I save it. And then I do the same thing again. I run this code again. It gives me exactly the same thing. Every pixel is 0, except for this 4 pixels. 50, 100, 150, 200. But this time I will save it as JPEG. So I will overwrite the JPG file. Now I close this one. I close this. So now I'm going to check these two files we just saved. I'll go to the TIFF first. I drag it in. I will magnify it. So now if I see, you see I go through this pixels, you check on the intensity value, you will see everything else, the value is 0, which means we keep the pixel as black. But this one is 50, 100, 150, 200. Everything else are 0, so that's exactly what our original image is. But when we open the JPEG file, I move around. First, let's say this one supposed to be 50. Now you can say it's actually now on in intensity is only 30. This one's supposed to be 100. You look at the value, it's actually now it's only 86. This one should be 150. Now it's 153. This one's supposed to be 200, but now it's 203. And actually some pixels around here supposed to be 0, but now it's actually half an intensity value. And if I go through the brightness and the contrast, the image adjust brightness and contrast, and you begin to see a lot of pixels around here, supposed to be 0, but now it's actually showing up a pixel intensity. This won't happen for the TIFF. No matter how you adjust this, it's always 4 pixels as the intensity with 50, 100, 150. Getting everything else is always 0. So the point is, when you save the image in a JPEG, it does change the pixel intensity. That's how the JPEG works. They adjust the pixel intensity, so they go through the algorithm, they try to make the file size smaller. So when you save the image, as long as you still want to use the image for analysis, always save them as TIFF. Never save them as JPEG. I would say never ever. I only save the picture as JPEG if I know I'm not going to use this for the analysis. I will only use this for, like I show this one in the PowerPoint. So those pictures, I save them as JPEG to save some space, because I know I only use them for the display. I will never use this kind of image for the analysis. So this is how you open and save the image. As we mentioned, it can open almost every single format of the image. You can also try that on the image you have. And once you go through any process analysis, you want to save the final result or any intermediate result images, always save them as TIFF. So I'm going to stop the sharing just to check on the, is there any questions you have on this? So like I said, I cannot drag drop my that I that I would say let's go to share the screen. You all the images you should be able to drag it in. I'm not sure what the kind of setting is in your computer. Sometimes the Mac can be different, getting. But you should be able to for the any images that. But anyway, you can always use the plugin, the bioformat importer, or sometimes try the file just to open. Getting. So if not many questions, we'll go through the second part. In this case, we'll just first go through the some simple measurement stuff. Okay? So assuming when you open on the image, you want to do some measurements that today we'll only cover the most basic one. So basically you draw the area where you want to measure and you ask the ImageJ to measure the parameters you want. So let's say if we go through the ROI and the measurement. So they have one image I call cells. Let's open this one. Okay. So those are the cell images. This looks like a color image, but actually just a single channel. I will change this one to green. So this image lookup table is how you want to show the image. I want to show them as a green color. It will seem like that. So I will say is that I want to measure this, count how many cells inside this field of view. And I want to know the size of each cell. And I want to know the total intensity of the green signal inside each cell. And once I know the size, I know the total intensity, I divide these two and then I get the average intensity. And eventually, I want to do it in an automatic way. I think I want to the software to do it for us. That's for the job for the tomorrow, for the beginner tool. For today, we'll just go for the in a hard way. If we cannot do it automatically, we just do it manually. So do it manually, basically we'll introduce some concepts called ROI, which is called the region of interest. So basically when you want to measure anything, the program needs to know where you want to measure, which pixels you want to include in the measurement. So you need to let the program know what is the outline. You need to draw the outline of the object you're interested to measure. So let's say if I zoom into here, I want to measure this cell. So I need to draw the outline, which is all object, the cell. A more kind of a generic term will be the region of interest. The region I'm interested to measure this. And to draw those, you have 4 functions in ImageJ to draw it, which is in the main menu. The 4 buttons here. So if you click on the rectangle one, in the PC you use the left button. You can just draw it. Okay? can draw. So this yellow box is my region of interest. So when I do any measurement, I measure all the pixels inside this cell. Okay? You can also say I want to draw one. You can, once you draw it, you can move it, change this one, and I think you can also move it. You can make this one, get the point, make it. But in most case, that your cell is not a regular shape, so you want to make it more freehand drawing. So in that case, this is a freehand drawing. You click on this, you hold on the left button, it just goes through it. So this is my cell. Yeah. But this case for freehand, you have to finish it in one drawing. Getting? You cannot stop. Sometimes when the object is really big, that can be tough. Getting? Or you can try. I use this one. This is a polygon. So basically, you click on this. You go to the next point. You click on it. It gives you the polygon. So the good thing is that you can have a rest. Getting? Later on, and you go back to keep going on. And then this is the selection. So most of the time, if you want to manually draw your object in the cells, you either use the polygon or use the freehand. Okay? Like for this time, let's say I want to do the freehand. I draw this. So this is my selection. And I want to measure the size of this cell and the intensity of all the green intensity inside. Okay? So that will do in the measurement. So for the measurement, what you will have is in the analyze, you have the measure and you have the set measurement. Those are very common functions you're going to use in the ImageJ. Getting? So let's first see the set measurement. So this one shows once you get a region of interest, we have this selection. What do you want to measure for this selection? Those are all the standard choices you can have for every single region of interest. Beyond that, you have to write your own code to do that. Okay? You have to base on those the measurements to get what you want. But those are the basic ones you can use built in ImageJ. So basically what we want the size, the area. We want the mean intensity inside this region. And if you also want the total intensity, they have a different name. What they call is a integrate density. That's actually the total intensity. It's basically the area times the mean intensity. And then you can choose you want any other. Maybe I want the minimum and maximum intensity inside this cell. I want the center mass, like where the center is. And we can also have the parameter. So what is the length of the outline for this cell? And maybe we can have something called the shape, like how round this cell is. So once I select this, I will say, okay, this is what I want to measure. I click OK. And then I'm going to measure it. This will be the plugin, no, the analyze, measure. So if you click the measure, this is your measurement for this one. The size is 5017. The mean intensity, as we zoom in, the mean intensity. So this is our selection include about 5017 pixels. So the mean intensity is about 58, close to 60. And this is the minimum intensity is 6, maximum is 246. And this is the position about the center of the cell. Right? And then they give you the parameters and also the different parameters you can use to depending on the shape. how circular it is. You can find the definition of these values on the ImageJ website. You go to their user manuals. And you can save this file in the result window. You can save it as a Excel file. I normally save as a Excel file. I will save it as the results XLS. So I will have the Excel file, then I can open this one. This is our Excel file. Okay. Later you have a more the ROI. You can do some statistic in the Excel. Okay. So this is in case you want to manually select your cell. You want to imagine. So and in some cases, and actually in many cases, you may not have a good way to do the cell selection or your object selection automatically. Okay? So it turns out by the end, you probably have to do them manually. Okay? No one wants to do that, but it is your data. If it has to do it manually, you just do it manually, very carefully draw the outline, and then you save the result. Okay? You not only want to save the result of the measurement, you also want to save the result how you draw this selection. What is ROI? So people ask you on this result, where are the cells? How you draw it? Did you draw it on the right cell or the wrong cell? Okay? So we also want to save this, how I draw this. Okay? So to save this, we will use a tool in the ImageJ called ROI Manager. So it manage all the region of interest you draw. So currently we have one ROI. We want to add this into the manager. So that manager is in the Analyze Tools ROI Manager. If you're going to use the ImageJ more, you will always use this function, the Analyze Tools ROI Manager. So it open is something like that. So I have this selection here. I want to add it to the manager. So I just add it. Now you can see, if it didn't show it, I click on this, then it shows on here. So the good thing for the ROI manager is now you can add more cells in it. So I will say I want to add this cell. I began to draw it. Okay. Then I say I want to add it. So now I have two of them. You can click this show all here. To show you this is 1 and 2. Then I can draw another one. Yes. You can either click add, or you can see there's actually a T here. You just press the T on your keyboard. It will also add it. And you can also, I choose this one. This is wrong cell. I don't like it. I can delete it. Now you only have this two. So basically you can manually draw them. I will say, let's say I draw 5 of them. I add it. I also draw this one. I have 5 cells. And I want to do the measurement, same measurement on all 5 cells. I just click the measure here. All the 5 of them, I click the measure here. It will give you, this is your result, 5 objects, 1, 2, 3, 4, 5, depends, corresponding to the order in the ROI manager. You can also show the label here. This 1, 2, 3, 4, 5. For every single ROI, in our case are the cells, what's the mean intensity parameter, and the how round it is. Okay. And I can save this one as the result. And then I also want to say how we draw those cells. When I show people the result, I want to say these are the 5 cells I draw. Getting? So I want to save this one. So that's in the ROI manager. You go to more. This is save. You save all the selections you draw. So I will save it. That's all the ROI. I will say selection. You can give it a name. And then just the ROI. I will save it. So now I close this one. Later you'll say, this is my cell. This is my result. I have 5 cells. It's a size, the mean intensity, everything. And people ask you, where are those 5 cells? So I will say, I save the selection in this one. This is the file we save. It's ROI underscore selection. This is a zip file. Don't do anything on the zip file. Do not unzip them. Just keep them as a .zip file. Once you want to open it, like any other file, you just drag it into the ImageJ main menu. It will open. So those are the 5 cells I draw. 1, 2, 3, 4, 5. And for the file number 5, this is the size. Which one is this? It's the number 5. It's this one. Okay. And then you can see I draw 5 cells today. I feel tired. I stop it. And the next day I come here. I will say, okay, I will begin to draw more cells. I'm going to draw this one. I will also add it. I will draw more. This, I add it. And also this one. And that's enough for today. So I will say, let's save it. I will override this one. And then I do the measurement. Now we have 8 cells. So now when we have the result, we have 8 cells. And where are they? Are those 8 cells? That's here. So eventually, if you have a clear idea what kind of object you need, what kind of a region of interest, is that in a cells or kind of a neurons, like the band in the Western blot, the gel scan band, you can basically draw them. You add it to the ROI manager. You draw all the objects. You make sure you add them here. You save the ROI selections. You go to the analyze set measurements. You ask it what I want to measure for every single ROI. And then you come here to measure it. Then you can save the result table as a Excel file, .xls. Okay? So that's the simple measurement. That's you do it pure manually. Ready? For tomorrow, we'll go through some process. If you're lucky, your image is good, we can try to make it more automatically for us. So you don't need to draw those cells by yourself. As you may find, sometimes actually quite hard to draw them. Ready? Especially those are the cells around. It's bad. It's kind of good. But sometimes if you're doing some very irregular shape, like a neurons, it's really hard to draw them live. Yeah. So this is how you want to do it manually. If you have to do them manually, you just very carefully draw them, add it to the ROI manager, then save it. Make sure you save it, and then later you can always change the measurement parameter. You want to add more measurement on it, you can measure it. And you can add more to the, right? You can add more cells. You can remove some cells you feel that's not the right cell, maybe just a dead cell. We want to remove it. You can do that later, anything. This one, number 2, I think is not good. I will delete it. Then I save this one again. Then then the selection won't include this cell. So I'll quickly sharing. Let's check on the chat. Uh, yeah, we will do that for the to optimize it. We'll do that for tomorrow. Yeah, getting. It's basically I cannot say it will guarantee to work. Yeah, getting. But many times, if your image, I would say, good enough, then you can do that automatically. But sometimes it's very noisy or very hard for the program to do this automatically. Eventually, you just have to do it manually. Okay? It's nothing wrong to do it manually. We draw this. I draw this cells. Getting. I think that's the best representation of the cells. I can show you how I draw it. Getting. It's okay, but it's just not kind of. It's kind of harder to argue with the review or some things that people may also think once you draw it, you kind of cherry picking it. Really? So the good way is that if we can do this automatically, that would be much better. But many times as I work with the users, it may not work. So if you have to do it manually, you just do it. Really? It's unfortunate it's your data. If someone have to do it, you have to do it. You may have 10 images. One image has 50 cells. You may take a whole afternoon to draw them. That's fine. Once you finish them, that's you finish it. Just make sure you draw them very carefully and you save the ROI.zip file. So if no other more questions, we'll go through some other things about the simple measurement. So one thing is that, as you can see here, when you do the measurement, this is measure the size, like for the first one. This is the first cell we draw. What do they say? The size is 5017. So you wonder, what is the unit of it? So normally when we measure the cell, that is size, probably the unit of a micron square. That's what you want. Okay? But here it's all like very whole numbers. So this means we actually don't know how much the size is in the real world. We only know how many pixels is it. As you can see, when you zoom in more, you begin to see the individual pixels. So when we're looking at everything we call the digital image, getting you already get a picture by the camera or by any scanning the mechanism. All you get on the image, on a single image, is a 2D matrix. You have a certain pixels in the x direction, you have a certain pixel in the y direction. Okay? Currently, we know how many pixels are here. I look at this image. You can look at here. We have 756 pixels in x direction and 756 pixels in y direction. But we do not know how big is that single pixel. Okay? All it knows is there's how many pixels inside this cell. You know the relative values. I know the cell number 1 is bigger than cell number 2. Cell number 2 is bigger than cell number 3, but I actually do not know what's the actual physical size, like in the micron square, how much it is. That is when the image, when they save the image, you lost the information. You actually, in most of the cases, you need that information to know the actual physical size. This, in another sense, if you think about it, it doesn't actually affect how you do the analysis on the image. Because once you have a digital image, all the analysis do it based on the pixel unit. Getting? They only know it as a pixel. Getting? The program only know it as a pixel. They work on the pixel. You only need the scale to convert it back by the end. We calculate how many pixels, but I want to know that one pixel corresponding to what exactly size is. So those information are saved, what we call the pixel scale. So you can check your pixel scale by the image, the property. If I check this one, we will see we don't have any pixel scale. 1 pixel is 1 pixel. We lost that. Yeah, getting? But if you have the raw image, yeah, getting? Let's say I close this one. I will go to the pixel scale folder. I go to like a Flybring. I open a Flybring. Getting? This is image of the fruit fly bring the Z stack. Now if I for this image, I go to the image property. You will see they actually have the information you want. They actually read it from the raw data. Here, every single pixel is about 2.6755 micron. So if I zoom in, this every single pixel is 2.5 micron. So now if I say I want to measure the size of this brain, I say I draw it. I draw it very roughly. Then I will say set the measurement. I only need to know the size. I only want to know the size. I close. And analyze, I measure it. So this is the size. This is like a 208,000. So you will see what is the unit of this one. This is the size. What is the unit? The previous one we have those are 5,017. That's the unit of the pixel. But this is the unit of a micron square because this is corresponding to what show up in this property. Now I know each pixel is 2.655 micron. So here it show up, this the unit is the micron square. If I change this to pixel, I remove it, I can lost the pixel information. Now the same ROI, I draw it, I didn't change it, I measure it. Now this is number 29,176. This is the unit of pixel, which means this ROI containing about 30,000 pixels inside. But those 30,000 pixels corresponding to this 208, 853 micron square because every single pixel corresponding to 2.6 micron. So generally, in all the modern system, let's say this is a size, the microscope image we just did. I use the. If you check the property, they have the pixel scale. So normally under the microscope case, all the modern system, when they save the picture, they save all the pixel information with the picture. It's what we call the metadata, getting? And all those, the ImageJ can read the metadata pretty good, getting? But they always suggest you, once you have your raw data, you open it in the ImageJ, you check it on the pixel scale and confirm this is same as you did in the acquisition software. Just make sure the ImageJ can read it right. Normally, I'm pretty sure it can read it right, but just to confirm. So as you have the raw data, the ImageJ can read the pixel scale. And then when it say do all the measurements, the units in the area will be what's the unit here you have. But somehow in our case, in that one, we lost the information. So something like this. Yes, the embryo. Now we check so we lost the information, but now if I want to measure the size of the embryo here, all we get the size is a pixel unit. We don't know what is the real size. So how do you know what is the real size? Uh, sometimes you can say it actually give you a scale bar here. If you can trust this scale bar, I will say if you can trust this scale bar, you can use this scale bar to set what the pixel scale is. Getting? So what you do is, let's say this is your scale bar. This is a line, so I will draw a line exactly the same as the scale bar, as corresponding to 100 microns. I will draw a line here, and then I will go to the Analyze, Set Scale. This is for you to adjust what the pixel scale you should have. So you will see they will measure this in pixels. This is about 473 pixels. So I will say what is a known distance? This should be 100 microns. Just keep in mind, this depends on you trust this scale bar. This is, we're assuming this is right. Getting? Now I click OK. Now it goes back here, property. Now it gives you 1 pixel corresponding to 0.211 micron. Because they measure the length of this line in pixel, and I know it's 100 microns, then you just calculate, divide it, 100 divided by 470 something, that's 0.11. So now you have the right pixel, and then you can say, okay, now when I draw this one, this is what, now the size 126.4, that's the micron square, because here the image, the property is is the right. So this is for the case you have an image. Sometimes it's kind of you lost the how you get the image. You just have the image somehow, but they add your scale bar by the acquisition equipment. You can do it like this. Okay? Or if you do not have the scale bar and your microscope is too old, you don't know what actually the pixel is. In that case, you have to buy something we call the micrometer. It's just a small ruler. You can put it under the microscope. You can buy something. There's a slide that's actually a very small ruler. You take the picture of the ruler under your microscope with exactly the same condition how you take your raw image. Then you know what the distance is. Then you use the set scale, the function, to get what the pixel scale. So I'm going to quit the screen. Any question regarding the pixel scale? Really? We will actually do another seminar we call the make sense of the measurements. In that, we'll actually talk more on the pixel scale thing. Okay? So just keep in mind, you don't really you don't really need this for the measurement. Getting? It doesn't ever change any measurement you have in terms of a comparison. You only need to convert the result in the size to the real physical one, the unit. Okay? It doesn't change any measurement, which cell is bigger, with which cell is smaller, that's compared to a different group. That's for the mammoth. Can we burn the scale from the image property? What do you mean a burn? I think you can unmute yourself. Now I said you can unmute yourself. You can want to.
Yeah. What I'm asking is we can define what's the pixel width from the scale. Can we do the vice versa? Like
you want to add a scale bar.
Yeah, scale bar. Add the scale bar.
Okay.
Like using the Zeiss on program that you can add the scale bar. Can we do on the ImageJ?
So let's say if I have this one.
Yeah.
I know what the property is. So you want to add a scale bar. You can go
Yeah.
to the analyze tool. This is scale bar. You have a several choice. You can, like it's 100
Oh.
micron. You
Mhm.
can choose where it should be.
Mhm.
It's very limited. It's not a very nice scale. I think once you know the pixel scale, I think you can go to other software. So
Mhm.
really, but you can use this one. How many? You can use it. I think it's 300. No? You can kind
Yeah.
of change the color. And once you click OK, then it's kind of what you burn it. It's actually
Yeah.
on it. But just keep in mind, once you do this, you cannot use this image for the analysis. You actually change the pixel intensity here.
Oh,
Therefore,
okay.
especially if you do that, like I will do lower right, I make it 500. So now I actually don't have the pixel in intensity here anymore
Yeah.
because the scale bar is applied to that. So
Yeah.
I would say you once you get a scale bar, you save it as you know this is only for the display what the scale
Yeah.
is. But when we actually I want to analyze the intensity or the intensity in here, now it's not the right one. You have to go back to the raw image to
Mhm.
measure it here.
Yeah. Yeah. That's correct. Thank you.
And I'll just use the last few minutes to go through the bit depths. Getting this is not this actually has nothing to do how we do the measurement. It's just sometimes you need to be careful. Let's say we have two images. Here I did in the day one, and in the next day I come to the same microscope. I take another picture. This is one. So obviously I want to compare the intensity among those two the regions. So I kind of draw this one here. I'm going to add it to the ROI manager. So I will say I'm going to measure this. I go to the day one, I measure it. And now I go to the day two, I measure it. Oh, sorry. This is only, I only measure the size. Apparently they are the same. I need to set this one to also to the intensity. I go to the day one, I measure this. I go to day two, I measure this. You will see day two, the intensity is way stronger than day one. That's almost 30 times stronger. Sometimes if you're interested to compare the intensity change between maybe there's a live cell, I wait for 1 day, I add some like a stimulus to the cell, the intensity change. But sometimes this is kind of too much. So actually here the change is not related to the actually the signal change. It's actually depending on how you measure, how you take the picture. You will say for the day one image, you will say here is actually 8-bit image. Day two is actually 16-bit image. So if you have the same image on your microscope, if you use the camera or the laser scanning confocal, you have the choice to make sure to decide what your image format is. If you go to 8 bits, the highest intensity will be 255. You cannot go over that. If you go to the 16-bit, your highest intensity will be 6,500, 5,000, something like that. So you cannot directly compare intensity between 8 bits and the 16 bits. Okay? And many times I want you to make sure when you take the image, they are taking it under the same condition. We do see it happen in real life that people have two images and somehow during between the day one and the day two, something changes. Maybe another user goes to the system, they set a preference on the camera to 16 bits rather than before it's 12 bits. And maybe in the laser scanning confocal, they change from the 8-bit to 16-bit. Okay? So you need to know when you take the picture, you need to know your picture are the same. So when we're talking about the image analysis, the most people think is we get the digital image. We have all the images in files, in TIFF, in any format. We began to analyze it. But you need to make sure the actually analysis starts with how you take the image. Getting? You need to make sure when you take the image, you take the best image you can get for the analysis. And when you take the image, you want to compare the image between different conditions. You need to make sure when you take the picture, you're taking it under the exactly same condition. This, we will have more example in the future, the seminars on that. So you need to make sure this is 16-bit and 8-bit, so you cannot really compare the intensity between this. Sometimes you may see that, oh, it goes to higher, and you feel your hypothesis also this should be higher, so you are very happy about that. Then you may not be ready to check into that. Sometimes if you are lucky, your hypothesis, this one, the day 2 under the condition should be much lower intensity. Why this should be much higher? You dig it more deeper, you found out actually this is 16-bit, this is 8-bit. So it's always many things can happen. You just want to make sure your image, when you take the image, when you open the image, always just check what is the bit size, what is the pixel scale, the property, getting to make sure they are the same. Then you can actually compare to more rely on this. Open the ROI manager is let's see. Whenever if I close this, actually whenever you draw ROI, you can just press the T on your keyboard. It will add the current one to here. That's the most people do to open this, but the standard way to open it is in the Analyze Tools ROI Manager. Okay? So today we're going to cover the simple things, and tomorrow we'll mostly try to say we want to use to create a mask binary image, and then we'll use the analyze the particles, the function, to try to generate the selections automatically. Yeah, getting? I believe that most of you also join for tomorrow. So if there's no more questions for today, we'll just end it now, and I hope we will see you tomorrow at the same time. Okay, so see you.